So for object 2, this is still all after. It's going northeast of 32 degrees. So I like to use visual. So we'll have our x vector and our y vector. So this is px prime and py prime. And I'm told, and I have my p net here. Okay. So again, I can find out my p net by using my maths that I was given. The velocity that it told me was after was 2.8 meters per second. So now I can find my p net. 17.08. So since I know this one, now bless you, then I can use my angle and my hypotenuse to find the other two. So cos of 32 degrees is equal to px prime divided by 17.08. So your px prime should be 14.484 Newton seconds. So that's an important number, so I like to box it. And then sine 32 is equal to py 2 prime divided by 17.08. So my py 2 prime is equal to 9.051 Newton seconds. Okay, another important number. Okay. So now that we found our x's of both and our y's of both, we add them both together. If you're running out of space on that page, you can just flip it over. It's blank on the back. Okay, so here's like the next part, is we take this assumption. The sum of x is equal to the sum of px prime. So the sum of px was equal to our px2 prime. I'll just go in order. px1 prime plus px2 prime. So the sum of px is equal to 4.528 Newton seconds plus 14.48 Newton seconds. So the sum of our px is equal to positive 19.012 Newton seconds. This is another kind of important number. Okay, then we have the next same assumption about our y values. So our sum of py is equal to the sum of py prime. So the sum of py is equal to py1 prime plus py2 prime. Sum of py is equal to 9.051 Newton seconds plus negative, make sure you didn't miss that one, negative 3.36 Newton seconds. So the sum of py is equal to positive 5.115 Newton seconds. Okay. So now we take these two values and we say everything from the beginning has to add up to this and this as its vectors. Now, in the beginning, one of our objects was just stationary, so its p was 0. So all of this will apply to the first object's movement. Okay? So does that make sense? Because this, all of the momentum that's after needs to equal all of the momentum before. Object 2 had no momentum prior, so then all of the total momentum must apply to object 1. So what we're going to do is we draw a new triangle to represent the momentum before of object 1, and we solve for the net. Okay?
What if they were both moving? What would you do?
So if they were both moving, we would have to have some information about, say, object 2. Say it was like 3.2 meters per second or something. You would find your p-value of this, and you would have to know if it's which direction it is, and you would minus that from the total, and then whatever's left over applies to object 1. Yeah, that's a good question. Okay, so as I said, that's what we do. Let's just do that now. So let's make a new triangle with the information we have now. So there's a lot of parts to this. You have to endure. And that's why I was like, make sure you write out if it's prime or if it's 1 or 2, just so that you keep all your stuff organized. Okay, so we have a positive x. So our p of x is 19.012 Newton seconds. And then our overall y was also positive, so I draw it like so, okay? Because remember, you need those x and their y's to be tip to tail. So our p of our y is 5.115 Newton seconds. Okay, then what you find is you're always looking, generally, for your net, okay, is what we need. So we can find our p net using Pythagorean's theorem. And when you put that in, your p net is equal to 19.688 Newton seconds. If you did your triangle like this, that's fine too. Yeah, but it will be the same angle, but just the flip direction. Yeah, it's fine. As long as it's tip to tail. Yeah, both are fine. Okay, so that's our p net, but we were looking for velocity. So now we just plug in its mass was 4 kilograms. V equals p over m. And our velocity, 4.92 meters per second. But that's only its speed. It asks us for velocity, so we need direction. So go to the tail of your net and you find the angle at that place. I'm going to use tan again, but you can actually use any of them. So my angle is equal to the inverse of tan of 5.15 or 5.115 divided by 19.012. So the angle is 15.058 degrees. You would have 90 minus that, right? Oh no, do you? Or would it just be the flip direction? Yeah, okay. So if we're at east and we went north of it, this is north of east. So now let's put it into sig digs and put our whole answer together. So our final answer is, and this is what, two sig digs? So 4.9 meters per second at 15 degrees north of